This is the first mini-lecture for section 2.2 of the syllabus, which corresponds to section 4.3 of the textbook. This section is about greatest common divisors and least common multiples. Remember in the last section I talked a little bit about how important it is to understand the meanings of the words divisor and multiple. If you really understand what those words mean, then a lot of this section should be self-explanatory. Okay, so let's begin with the first concept, greatest common divisors. If a and b are whole numbers, not both 0, then their greatest common divisor, written GCD of a and b, is the largest whole number that is a divisor of both. For example, the greatest common divisor of 18 and 30 is 6. 6 is the largest thing that goes into both of those numbers. It's the largest whole number that is a divisor of both 18 and 30. So let's find the greatest common divisor of 60 and 96. Okay, one way to do this is to simply list all of the divisors of each number. And we can do that with the rainbow diagram. We already did 60 on the previous slides, but let's go ahead and redo that. So we have 1 times 60 2 times 30 3 times 20 4 times 15 5 times 12 and 6 times 10. And those are all the divisors of 60. Now let's do the same thing for 96. We have 1 times 96 2 times 48 3 times 32 4 times 24 Okay, 5 is not a divisor. And then we have 6 times 16. Seven is not a divisor. We have 8 times 12. And 9 is not a divisor. 10 is not a divisor, and 11 is not a divisor. We get up to 12, and 12 is already on the rainbow. It's on the right-hand side of the rainbow. So that means that we're done. So these are all the divisors of 96. And I just have to compare the two lists and see what do they share. We just circle everything they share. They share 1, 2, 3, 4, 6, and 12. And the largest thing they share is 12. So the greatest common divisor of 60 and 96 is 12. So provided we can list all the divisors of the two numbers, this always works. You can always do it in principle, but as we've seen, sometimes it's hard to list all those divisors. If the numbers are large or hard to factor, you're going to have a harder time doing that. So one alternative would be to use prime factors. Remember, in the last section, we saw that we could use prime factors to list all the divisors of a number. Even though that was a little bit tricky, but in principle the idea is simple. You're just listing all of the different combinations of those prime factors. Well, we could use that same idea to find the greatest common divisor of two numbers. Let's try to do this for 60 and 96. Okay, 60 is 6 times 10. 6 is 2 times 3. 10 is 2 times 5. Okay, 2, 3, and 5 are all prime. Okay, then we have 96. 96 is, well, it's 4 times 24, like we just saw. 4 is 2 times 2. 24 is 6 times 4. 6 is 2 times 3. And 4 is 2 times 2. So 96 is 5 2s and a 3. 60 is a pair of 2s, a 3, and a 5. Now here's what I'm going to do. I'm going to write the two numbers side by side, one above the other, and I'm going to line their prime factors up. So at 60 we have a pair of 2s. 96 we have 5 2s. 96 also has a 3. 60 has a 3 and also a 5. So if a number goes into both 60 and 96, then its prime factorization has to be seen in both 60 and 96. So if I take the largest group of primes that 60 and 96 share, the product of those primes should be the greatest common divisor. And I see they share a 2, a 2, and a 3. So the greatest common divisor of 60 and 96 is 2 times 2 times 3, which is 12, like we just found. Let's try this same idea for another pair of numbers. 840 and 490. These two numbers, it would probably take a while to make a rainbow diagram for them. And the diagram would be probably too long for us to want to do that. So instead of doing that, let's make factor trees and use the prime factors. Okay, 840 factors into 84 times 10. 84 is 4 times 21. 10 is 2 times 5. 2 and 5 are both prime. 4 and 21 are both composite. 4 is 2 times 2. 21 is 3 times 7. So let's see, we have 2, 2, 2, 3, 5, and 7. Okay, now 490. 490 is 10 times 49. 10 is 2 times 5. 49 is 7 times 7. 2, 5, and 7 are all prime. Now we'll compare. So 840 equals 490 equals. 840 has 3 2s. 490 has just 1 2. 840 has a 3. 490 does not have any 3s. 840 has a single 5. 490 has a 5. 490 has 2 7s. And 840 has just 1 7. Okay, so there's those two numbers side by side. Now what do they have in common? A 2, a 5, and a 7. So the greatest common divisor of 840 and 540 is 2 times 5 times 7, which is 70.